Now the next problem is like this. Take down the problem. Obtain Taylor's or Laurents series which represents the function which represents the function f of z is equal to 1 divided by 1 plus z square into z plus 1. Okay, when the first condition 1 less than mod z less than 2. Now see, purposely I am writing 2 like this so that there should not be any confusion between z and 2. And second one is mod of z is greater than 2. I have not done this particular problem, no students? Okay, you can hear me, right? Yes. Because now I will not be able to see the chat box. So if you want to say something, please say on the mic, okay? Because I'm sharing the screen. Okay, it's okay, students. You can hear me, you can see the screen, right? Okay. So now let us start the solution, students. Now see, in this particular problem, usually in the problem, they will give you the region where you want to find out the Taylor's or Laurents series. So in this here, it is given that your function is uh, f of z, which is equal to 1 upon z square plus 1 into z plus 2, right? Now in this case, see what we do. First of all, what is the first step if you remember? First step is definitely partial fractions, right? We have to split the function. So let us find the partial fractions. So it is f of z is equal to 1 upon 1 plus z square into z plus 1. Now see how you are going to write the partial fractions for these students. Because if you observe, the first term is quadratic, right? 1 plus z square. So how you write partial fraction for quadratic? It will be az plus b divided by 1 plus z square, and plus second factor is linear factor z plus 1. So it is c divided by z plus 1. So in all these problems like Taylor series and Laurents series, your first step is partial fraction. You have to split the function. Okay. Right now side, so it will be az plus b multiplied by z plus 1 plus c multiplied by 1 plus z square. Okay, and then the denominators are getting cancelled. Now the next step is to get values of a, b, c as usual. So what are the things you are going to do? How you are going to get values of a, b, c? Either you expand whole right hand side and equate the coefficients on both sides, or another way is like suppose I put first, if I put z is equal to -1, then what will happen? 1 will be equal to, first term will be 0, right? Because 1 minus 1 will be 0, plus minus 1 square is plus 1. So 1 plus 1 is 2. So it will be 2c, and then you get c is equal to half, right? One value you got. Anything you are getting by putting z is equal to 0, let us check. It is just trial and error method, students. Somehow you have to get values of a, b, c, right? So if I put z is equal to 0, I'll get 1 is equal to az. Az means 0. Then b, and z plus 1 means it is 1 plus c into 1 plus z square. Z is 0, so it is just 1. Okay, so you got b plus c is equal to 1. Correct? But what is c you got? C is half. So it is b plus half is equal to 1. So what is value of b here? 1 minus half is half. So you got b is equal to half and c is equal to half. Right? Now what is remaining? A is remaining. How you will go for A? To find value of A, you can definitely equate the coefficients of z square on both sides. Right? So because you cannot use any substitution for z, so that one term will get cancelled and you will get value of A directly. So what do you do here? Equating coefficients of z square, no? It is coefficient of z square coming. So see what is value of A you are getting. B and C you got already, half and half. Correct, no? You see what is the another value you get? Az plus B upon 1 plus z square. So az plus B into z plus 1 plus C into 1 plus z square. So I am putting z equal to minus 1 first. So it is 1 is equal to minus 1 plus 1 is 0 and this is 1 square. 1 square is 1. So 2c. So c is equal to half. Then I'm putting equal to 0. So 1 is equal to b into 0 plus 1, that is b and plus c. C is half, so b is also half. Okay, now how you are going to find value of AC? Anybody getting value of A? You can tell me. Okay, one correction you do, students, here. Well, I was thinking, now see, here what you do know, in the main function, instead of taking the denominator this 1, take here 2. Just see, students, please all of you make this change, otherwise our answers will differ. Make this 2, students. Are you listening, all of you? See, first bracket you don't change 1 plus z square as it is, and then take this as z plus 2. Okay. So here, wherever there is z plus 1, you are making it as z plus 2. Only change 1 to 2. So here also on the other side it will be z plus 2. Okay. Then here also it is z plus 2. Okay. So what will be the changes happening here? When you put z is equal to minus 1, it will be 1 is equal to 0. Uh, what will be this term? C will be same, half, correct, no? Because z is equal to minus 1, you cannot put z is equal to minus 1. It will be z is equal to minus 2. Then only this full term will become 0, right? So this will be 2 square is 4, 4 plus 1 is 5. So here you are getting 5, right? So C is equal to 1 by 5. That is gone. C is equal to 1 by 5, right? Then you are putting Z is equal to 0. So what about to be this? 1 is equal to B into Z plus 2. So here it will be 2, right? And C into 1, that is correct. Now already your C is what? 1 by 5. Correct? Here it is 1 by 5 and this is 2b. 2b plus c is equal to 1. So 2b plus 1 by 5 is equal to 1. So what will be b here? B will be b will be 2b will be, first of all we'll find out 2b is 1 minus 1 by 5. So it will be 4 by 5. Correct? 4 by 5. And what will be b now? B will be 4 by 10, no? 4 by 10 cross multiplication, that is 2 by 5. Okay, so your B is 2 by 5, C is 1 by 5. And now what is remaining? It is remaining to find A, right? To find A, what I told you, you equate the coefficients of A is what? A is coefficient of Z square, no students, see here. We want to find value of A, so just concentrate on this term. So this is not A into Z, it is A into Z square, because when you multiply these two brackets, wherever A exists, that you have to see. So in short, left hand side is 0 Z square, right? There is no term in Z square. So I am writing 0 Z square is equal to, now only terms in A I want to collect on right hand side. So first term will be what, students? A into Z square, right? And then second term is what? 2. So 2AZ plus 2AZ. So all of you understood from where I'm getting this? I'm just multiplying these two brackets, first two brackets, this bracket, and this bracket, right? So I'm doing multiplication. I'm not interested in this term at all, because here already we got value of uh, 0 square, and the coefficient of Z is also 0 there. We are interested in terms in Z square. Right? So we are interested in only coefficient of Z square. So one more term you are getting. So C into Z, terms in Z square. Okay. So A plus C will be equal to 0. Out of that 5. So A is equal to minus 1 by 5. Any doubt, students? Please unmute and tell me if you have any doubt, or even if you don't have doubt, please say something. Hello, students. Am I sharing the screen? What happened?
Yes, ma'am.
Yes. No, better I will open my Meet on mobile also, because I'm getting confused. I cannot see your names and the screen. So I don't know. I need to just wait. Huh? So have you all understood how to get values of A, B, C? It is just the partial fractions which you use for your this also Laplace transform also. When you find Laplace inverse transform, you get this. You have to use partial fraction method. Correct, no?
Yes, ma'am.
Okay. Okay. So if you want to say anything in okay, if you want to say anything, you can say on chat box, students. Huh? No problem. Okay. Now let us continue on the next page. Now what we did, just we got values of A, B, and C. So this is the first problem. Is it okay? You can hear, no?
Yes, ma'am.
Okay. Now let us continue with the next part. So let me rewrite what I got here. I got f of z is equal to um, what is that? Az. What is a we got? Minus 1 by 5. Minus 1 by 5z plus b. What is b we got, students? B value of b is 2 by 5, no? So it is minus 1 by 5z plus 2 by 5, correct? Divided by 1 plus z square and plus, what is the next value? C. C is 1 by 5, right? And divided by z plus 2, correct? Now let us write it little bit properly. Like 1 by 5 is common from the numerator. So let us take minus 1 by 5. Okay? And what will happen? Negative term will become positive, positive term will become negative. So how it will look? Z minus 2 it will be divided by 1 plus z square. And from second term, I can take 1 by 5 out and 1 upon z plus 2. Okay. So see students, this is just the arrangement we have done. Okay. This is the same function. We use the partial fractions and our aim is to convert this in the form of either Laurents or Taylor series. So it is just the rearrangement of the same function. Okay. Now, now our main solution part starts. Now what is the condition? See, in the first condition, you have mod of z. See, the first case is correct. So all these things are related to the circle, students. What is meaning of this part? This is nothing but you have to consider two concentric circles because mod of z is in between 1 and 2. Means these are two circles. How these circles are? One is 1 and here this is radius 1. Okay, circle is and the center is 0 0 and the second circle is with radius 2 because the right hand side is 2. So this is the second circle 2 with radius 2. Okay, and where is z? Z is, no sorry, this 2 I have to write like this. This is the radius, students. And where is z? Z will be here because this mod of z is less than 2 and greater than 1. So which is the region of convergence here? Region of convergence is this dotted area in between. Right? This is your region of convergence. Okay, all of you understood? Now, in the first expression, because see, this function or your condition is first part and what is the second part? Mod of z less than 2. Correct? So what happens is when you express your denominator of the function, as I told you, you have to make the right hand side 1. Right hand side 1 means what will happen, students, here? If I interchange the places, the middle sign will change. Right? So how I'll get? I have to divide both sides by z here. Correct? And here I have to divide both sides by z. So it will be 1 by z less than 1. Correct? Actually, it will be mod of 1 by z less than 1. Mod sign you can give to the numerator also. And here mod of z by 2 is less than 1. See students, again I am telling you, whatever is the condition, you make it as less than 1. So what it means? It means that your region of convergence is within that circle where the radius is 1. So always every expression you have to convert in the form of less than 1. Another benefit of this is when you are converting your denominator in terms of 1 upon z and z by 2, you are getting one term as unity and that is giving you the standard series. Now see, for example, in this problem, once you make it less than 1 at both places. Have you understood what I did here? This is very important step. Now I'm going back to my f of z. Okay, this is f of z, right? Where it is gone. Okay, this is f of z. Now we are going to target this. Okay, now in this, see what I do. The outer constant I'm not touching, minus 1 by 5. Now even I cannot do anything with the numerator z minus 2. Okay, now denominator, what I'm going to do is, this is 1 plus z square in the denominator. So what I want it as 1 upon z, right? So I have to multiply and divide by z square. And the bracket will be z square by z square is 1, and this will be 1 by z square. Array, what happened? There is no redo. Just a minute, students. Okay, change the color. Okay, so what I was saying, when I write my first expression is for the condition what? 1 less than mod z less than 2. So I'm dividing it in two parts. 1 less than mod z. What this implies? It implies 1 by mod z is less than 1. 2. What this implies? Mod z by 2. Expression f of z is equal to. Now in the what is our f of z? Let me write my original f of z, which is 1 minus 1 by 5. Then z minus 2 divided by 1 plus z square plus 1 by 5, 1 upon z plus 2. I have not done any changes till now, students. But now what I do, I want 1 by z in the denominator of first term. Okay. And in the denominator of second term, I want mod of z by 2 or z by 2. So here what is required? Minus 1 by 5, I cannot do anything. Then numerator z minus 2, I cannot do anything. Now denominator, I want, see 1 by z is less than 1 means 1 by z square is also less than 1, right? So here only you can mention 1. This implies 1 by z square is also less than 1. So we are interested in less than 1. So I'm multiplying by z square and inside I'm dividing by z square, see. Okay. So I have written z square term first. So z square by z square is 1 and 1 by z square. Plus, why I have done this, you all of you understood, because 1 upon z square is less than 1. Similarly, plus 1 by 5. In the second term, what we do? By what you have to multiply and divide? Can you tell me, anybody? By what you have to multiply and divide this denominator? Others, can you tell?
Hello, ma'am. Z plus 2.
Huh? By what you will multiply and divide? 2 or z?
And Z plus 2.
No. By what you will multiply and divide? Akash? Can you tell Akash?
Yes, ma'am.
By what you will multiply and divide this denominator? See, you want z by 2, right?
Ma'am,
Z
two.
by what is less than 1? Z by 2. So you have to convert it in the form of z by 2, and for that purpose you have to multiply and divide by 2. So you will get 2 by 2 is 1 and this will be z by 2. Okay. So this is equal to minus 1 by 5 z square. Then this z by 2, z minus 2. Then this 1 plus 1 upon z square will come on top raised to minus 1 plus 1 by 10 1 plus z by 2 raised to minus 1. See, you have to get a term in 1 here in the bracket because you have standard series students. What is 1 plus z raised to minus 1, which is 1 minus z raised to minus 1. So before making one term unity, you have to take care of the interval what is given. And that's why you have to arrange your interval as something less than 1. And that time you had to cross multiply by the corresponding number. Okay. Now here what we do, see students, it is minus 1 by 5 I can keep as it is. And this is z minus 2 upon z square. No, so each term I'm dividing by z square. So I'll get it as 1 by z and this will be 2 by z square, right? Just I'm multiplying. This is the standard series. Correct? No? Then minus 1 z cube. Z cube will be 1 upon z raised to 6 and so on. Then plus 1 by 10. Again expansion for this 1 plus z raised to minus 1. Where z is z by 2 here, right? Z is z by 2. So it is 1 minus z. Z means z by 2 plus z square means z square by 4. Then minus z cube. Z cube means z cube by 8 and so on. So these are the standard series, correct? No? And now see what you get. Little bit just write it by multiplication. So 1 by what happen? This signs will change, right? This will become minus and this will become plus. So term by term, if you start multiplying, then this will be minus 1 by z, then minus minus plus 1 by z cube. See students, I'm multiplying by this to this bracket, right? Then what I'll do? After writing 2, 3 terms, I'll multiply this bracket by this 2 by z square. So this bracket contains infinitely many terms, right? So we cannot write all the terms. So term by term multiplication I'm doing. Then I will get minus 1 by z raised to 5, correct? Then I will get 1 by z raised to 7 and so many terms. Then plus. Now let us start multiplying this term to the bracket. First we multiplied by this term, right? Now we are multiplying by this term. So now what happens? Minus will become plus. So 2 by z square it will be. Then the second term will be what? Minus 2 by z raised to 4. Then plus z by z raised to 6. Yes. And so on, right? So even if you write the 3 terms or 4 terms, it will do. Then what? Then plus. Plus now this, right? Now out of this 1 by 10 already we have taken 1 by 5 out. So 1 by 2 is remaining. So let us multiply the bracket by 1 by 2. So I'm not putting separate bracket. In the same bracket I'm writing. So it will be 1 by 2 minus z by 4 plus z square by 8, isn't it? Nothing I'm doing, students. I'm just multiplying this by 1 by 2. So 8 by 2, 8 into 2 is 16 and so on. Okay. And now if you observe, this is your Laurents series. This is your Laurents series. Why this is Laurent series? Because if you see, some parts are containing odd this what is that negative powers of z, because if you take these terms to numerator, this is plus 3, it will become minus 3, then plus 5 will become minus 5, and there are few terms with positive power of z, right? You can write one more step by combining all negative and positive powers, and the series which contains negative and positive powers of z is called as Lorentz series. And if all powers of z are positive, then it is your Taylor series. So the main difference between Lorentz and Taylor's is, in Taylor series, all the terms, all the powers of z are positive. In Lorentz series, it is divided in two parts. One part is having positive powers of z, and other part is having negative powers of z. Now the series which contains only negative powers of z is also called as the Lorentz series, because it is a part of Lorentz series. Any doubt, students, in this part? And this is the region of convergence is in between two circles which I have drawn previously. Okay. Now this is not the end of problem. One more second condition is still remaining. What is the second condition? It is mod of z greater than 2. Now if I ask you to draw the circle, it is first you have to draw the circle with center as origin, or as usual, correct? First you consider this inequality as equality. Think about mod of z equal to 2 and draw the circle, and then see the condition. Okay. So 2 is the radius, no students? So this will be somewhere here, it is 2, correct? But what is z? Z is greater than 2, means where will be z? Z will be outside, right? Here somewhere. Mod of z is greater than 2. So your region of convergence is where, students? It is outside this circle, correct? Now, as I told you, in the given expression, how we are going to write this? Mod of z is greater than 2. So how you are going to write it? As I told, first of all, you have to make it as less than 1. So is mod of z greater than 2, isn't it same as 2 less than mod of z? Just have interchanged. This 2 is taken to left hand side, this is taken to right hand side. The sign I am not changing, see. I am not taking reciprocals. Try to understand this. It is the same thing I wrote. Only see, when I write A is less than B, it is same as B greater than A, no? Or if I write 2 less than 3, isn't it 3 greater than 2? Meaning is same, right? So it is the same thing I am doing here. So what I wrote here is mod of z greater than 2 is same as 2 less than mod z. In other words, as I said, we want 2 by mod z less than 1. This is must. Mod of something less than 1 is must. Then we get the direction of converting our denominator in the particular form. Now see, students, when I say 2 by z less than 1, what will happen with 1 by z? Mod of z is greater than 2, means mod of z has to be greater than 1 also, no? See, this also implies mod of z greater than 1, even if it is not given, 1 will be somewhere here, right? So when you say z is greater than 2, definitely z is greater than 1. So if you look at this will give you z by 1, or we'll write it as 1 less than mod z, correct? This same thing I've done. A greater than B means B less than A. So 1 by Z is less than 1. So why I have done this? Because I wanted to do it as less than 1. This is less than 1. So you concentrate on these two things. So this is your first step. Any doubt, students, still here? And now back to your expression. If you have any doubt, please ask me. Your expression is what? Let me write the expression. F of z is equal to minus 1 by 5, then z minus 2 divided by 1 plus z square, then plus 1 by 5 upon 1 upon z plus 2. This is our original expression for f of z after getting it into partial fractions, right? Now, according to our conditions, we have to convert. Like we want the term 2 by z and we want the term 1 by z. 1 by z is less than 1 implies see 2 is less than 1 4 by 4 is less than 9, right? Z square is also less, so I want 1 by z square. So definitely I have to multiply and divide by z square, right? Correct? So it will be 1 1 upon z square plus 1 means z square by z square is 1 plus 1 by z square. You can interchange two terms, students. So that first term will get 1. Okay. So z square by z square is 1 plus 1 by z square. So we got 1 by z square plus 1 by 5. Now who will tell me by what you will multiply and divide the denominator? Bipin, can you tell by what you will multiply and divide this denominator? Hello, Bipin, are you there? Okay, what about Fazila? Fazila, can you tell me by what you will multiply and divide this denominator?
By Z.
Mm, by z, correct. Very good. Because you want z by, sorry, 2 by z. See students, whatever is the condition, no, you just concentrate on this condition. 2 by z you want. So you have to multiply and divide this by z. So it will be z into bracket, z by z is 1 and this will give you 2 by z. Okay. And then as usual, this is minus 1 by 5. Then this z square. Then this is numerator, I am not changing, z by 2. And this 1 plus 1 upon z square plus 1 by 5 pi z 1 upon 1 plus 2 by z. Now see, purposely I am writing 2 in different manner. When I write this, this is 2, right? And this is my z. So don't get confused between 2 and z, students. So it is equal to, now minus 1 by 5 z square. This z minus 2 I am not touching at all. And this 1 plus 1 upon z square I am bringing to the numerator. And the sign of the exponent is minus 1. Correct? Plus 1 upon 5z I am not touching at all. And then 1 plus 2 upon z raised to minus 1. So denominator bracket is brought to the numerator. And now like last case, this minus 1 by 5 I can make plus 1 by 5. And what I'll do, this I will make positive. So 2 by z square and this will become minus z by z square is 1 by z. So two things I have done together, students, here. I have cancelled this minus sign. In other words, I have taken this minus sign in. So this plus z becomes minus z and minus 2 becomes plus 2. And I am multiplying this bracket by 1 by z square. Okay. And now this expansion is what? 1 plus z raised to minus 1 is what? 1 minus z. In place of z, what you have? 1 by z square. Plus z square means it will be raised to 4 minus z cube means 1 upon raised to 6. Correct? And so on. This is our normal expansion. Then plus 1 by 5z into bracket. Again same expansion. 1 plus z. Z means 2 by z. 1 minus, no? This sign will be minus here. Then plus z square means 2 square is 4 by z square minus 8 by z cube Then if you want, you can write one more term, 16 by z raised to 4 and so on. And then like last case, you have to combine all these terms. So 1 by 5 you can take common, which is there in both the terms. Then multiply these two brackets. So see how we are getting the terms. It is minus 1 by z plus 1 by z cube nothing I'm doing students, I'm multiplying minus 1 by z raised to 5, right? And so on. Then the second term comes into the picture. Means which term? This. You have to multiply the bracket by 1 by z. Which bracket? This bracket, right? And what are the terms? 2 by z square minus 2 by z cube, right? And so on. And the last term, multiply this bracket, whole bracket by 1 by z. So what are the terms you are getting here? 1 by z, 1 by z, then minus 2 by z cube, right? Minus 2 by z square, no? Z square, then plus 4 by z cube, and so on. So nothing much is there, complete the bracket. And this is the required Laurents series. The speciality here is all powers of z are coming negative because all the z's which are there in the denominator, see here, all are z's in the denominator. In every term, the z is in the denominator. So all are giving negative powers of z, right, when you bring them to the numerator. So it is a part of Laurents series. So you can say that this is the required Laurents series. Okay. Now one more problem I want to take, students. Hmm. Hmm. Take down the problem. Expand.
Already time up.
Time up. How much time is left, Ray? F of z is equal to how many lectures we'll be getting, Ray? Today is the 7th, no? So one week we are getting, right? So no problem. F of z is equal to z plus 1. Have you started solving the tutorials? Any problem in uploading the tutorials? Now here in this problem, students, there are different conditions given. If you can try this and tell me how you are going about it. See if you can do this, sir. See what it is. The function f of z is equal to 1 upon z plus 1 into z plus 3. Okay. And this is converted in the Laurents series with 4 conditions. Mod of z is greater than 1, less than 3. This is the first condition. Then second condition, mod of z is greater than 3. Third condition is 0 less than mod of z plus 1 less than 2. And the fourth condition is mod of z less than 1. So just try this. At least first two you should be able to do because it is very much similar to the previous problem. Okay, first two you try, last two we'll do in the class next time. Okay. Yes. Now you can give the attendance, students.